More classrooms using digital platforms, apps, and interactive tools, it's easy to think that adding technology always improves learning. But both research and classroom experience show that technology alone doesn't guarantee engagement, doesn't guarantee understanding or achievement either. Choosing the wrong digital activity can waste time, just like a poorly designed assignment. This is why teachers should be thoughtful and careful when deciding how to use technology. Teachers don't need to use technology for every lesson because not all learning tasks benefit from it. Some math skills are better learned with low-tech methods like paper and pencil. Mental math, hands-on tools, or in-person discussions, especially like physical manipulatives. For example, when students are practicing arithmetic fluency, sketching graphs by hand, or organizing their written reasoning, like the claim evidence reasoning model, using paper pencil helps them slow down and think about it more deeply, and students remember the ideas better when they write by hand, take notes, and work through steps on their own. If teachers don't choose technology carefully, students might rush through tasks and just click buttons without thinking deeply about the material itself. Even so, there are many times when high-tech tools are very helpful. Dynamic graphing software lets students quickly see how equations change. Data tools help them analyze large sets of information. Like things like GeoGebra and Amplify give platforms for instant feedback and let students work with expressions in a way that paper just can't. The goal isn't to choose only technology or only traditional paper pencil methods. It's about finding out the right balance between the two. So some low-tech tools are seen and very strong with written reasoning, sketching and modeling tasks, showing work step by step, and then it can also help reduce distractions in the classroom. High-tech tools are very strong for dynamic visualization, giving instant feedback, just showing multiple representations, and then giving students access to real-time data. So the most effective classrooms don't do either one, they do both. For example, a teacher might begin a lesson with an interactive graphing tool to help students explore patterns, but then the class could switch to paper pencil so students can explain what they found and solve problems independently. Using both approaches together often helps students learn way more than just using one method throughout the entire curriculum. The first question is before using technology is, does this technology improve learning? Is it just replacing paper and pencil with a digital form? If a tool only turns a worksheet into an online version of itself without adding any value, it may not be worth the time or possible distractions from using devices. Think of the SAMR model. We really are looking for modification redefinition when using technology in the classroom. The next question is, what mathematical thinking does the technology want to use support? Does it help students see relationships or get feedback connecting ideas better than with paper or pencil? If the answer to that question isn't clear, the technology tool might not be worth using. So could this technology create misconceptions for shortcuts? For example, students use calculators before they understand basic arithmetic or use graphing tools before they know about the X and Y axis and scale. Technology can sometimes hide weak understanding instead of building that conceptual understanding. Next is, will students stay focused on learning or focused on the device? Technology can make students more engaged, but it can also be a lot more distracting. If students spend more time navigating menus or thinking about math, the tool isn't helping their learning. So if like the technology is very clicky, and students will be easily distracted by it. Next is this tool accessible for all students? So teachers should be able to think about if the tool is easy to use, how readable it is, and whether it supports different classroom demands, like students who might not speak English as well, or students with uh, sight or hearing impairments, making sure you need to make sure that if devices are available, all students can take part in interacting with the device successfully. Another important question is about non-digital alternative, or what is the best non-digital alternative? So sometimes technology is the best choice. Other times, a whiteboard discussion, hands-on tools, or a notebook might work just as well. So this balance is especially important in math because students need to both understand the concepts, the conceptual understanding of the topics, or procedural fluency. So technology can help with understanding through visuals and interaction, while paper and pencil often build fluency, organization, and independent thinking. So using technology wisely also respects teachers' expertise. Good teaching doesn't just come from using an app or just using GeoGebra. It comes from teachers making thoughtful choices based on learning goals, something that has always been implemented in lesson planning. So overall, technology should be used when it clearly helps the instruction, not just because it's available. The most effective classrooms balance digital tools with traditional methods so students can get the benefits of both throughout the entire year.